So in this video we will look at trigonometric ratios as distances. And why look at trigonometric ratios as distances? Ratios are hard to sort of understand, but when I can see it as a distance, I can see how it changes, what happens to it, how it depends on other things and so on. So that's the idea here. So in this you start with the unit circle. Unit circle has a radius of 1. You can assume this is a circle. It doesn't quite look like a circle. So since opposite side by hypotenuse was equal to 1, so opposite side is actually equal to this. The sine theta is opposite side times hypotenuse. Here opposite and hypotenuse is 1, and this is the angle, let's say theta. So since this was equal to sine of theta, the opposite side here is sine theta. So this is sine theta, that length is sine theta. Okay. Similarly, since the adjacent side, which is here, divided by hypotenuse is this color, hypotenuse was equal to cos theta, this length is cos theta. So if you have a unit circle and you have an object that's going around the unit circle, then the height of that object is sine theta and the width of that object is cos theta. Okay. So the question is, what is the advantage of this, of looking at it like this, right? So the first thing is, I understand then that sine theta, the height here for example is 0 and it's increasing, but at the maximum value it can go is 1. So the magnitude of sine theta, right, it will also go to minus 1 here. The height is negative here, the height is positive here, the height is negative here. So sine theta, the magnitude of sine theta, right, the magnitude is always less than 1 because it's always within the unit circle. It's the height within the unit circle. The height will always be less than 1. And of course you can see obvious things like sine of 0 is 0. There's no height here. And the sine of 90 degrees, if you're looking at it in degrees, is 1. Right? Or you can say pi by 2 is 1. And then you can see that here again it becomes 0, so sine of 180 becomes equal to 0, and then you go the other side, so you go sine of 270, which is negative 1, these are all in degrees, and then sine of 360 is again 0. The other thing you can see very easily is that the height is positive in the first two quadrants. So basically sine is positive here because it's the height, yeah. So sine is positive in quadrants 1 and 2 and negative in the other quadrants. You can just see it with the height, what is happening to the height. The height is positive. Positive means above the x-axis. So that's positive, and then it becomes negative here and here because the height is lower. So that basically tells you about sine theta. Right? Similarly, if I look at cos theta, again cos theta is now the length in the base, right? So as the triangle is moving, that's sine theta and this is cos theta. I can see that cos theta has the same one property which is similar, that is cos theta magnitude is also less than 1. Why? It's always inside the unit circle, never crosses the unit circle. It never crosses the circle of radius 1. So it is inside 1, so it is less than 1, and maximum value it can have is when it is 0. So here we can see cos of 0 is 1. We can see cos of 90 when it goes all the way to the top becomes equal to 0. Cos of 180 becomes negative 1, not positive 1. And then cos of 270, that's here, there's no length, so that again becomes 0. And cos of 360, it's come back all the way, that becomes 1. So the other thing you can see is cos is positive here and then once the point moves the second quadrant, cos has become negative. In fact, it stays negative. We go there and then you come back, and then again it becomes positive. So what you see about cos is that it's positive because the length, it's positive in the first and the fourth quadrant, right? Sorry, it's positive in the first and the fourth quadrant, and here it will be negative, which is the second quadrant and the third quadrant. So yeah, you can still do all silver teacups. I guess people are familiar with that, which means all of them are positive. Sine, cos, everything is positive in the first quadrant. In the second quadrant, it's mostly the sine, so cosecant, that is positive. In the third quadrant, the tan is positive, and the fourth quadrant, the cos is positive, but sine is negative and tan is negative, and so on. So this gives us, looking at the trigonometric ratio as distances, in this part 1 we are looking at sine and cos, gives us a sense of what's happening to sine and cos. And actually this is something many people are familiar with, especially since we use something called we usually use x and y, which is the coordinate system, right? But you can also represent it as r and theta, right? That's our polar system. And converting from polar system to rectangular system, you basically multiply r into x is cos theta and y is r sine theta. So this is fairly standard. This is something that all of us use when you are converting from polar into the coordinate system xy. And of course, if you wanted to find r, that would be square root of, if you wanted to go the other way, then r is square root of x square plus y square, and y is equal to, theta is equal to tan inverse y by x, the ratio of y by x, tan inverse of that, because that's tan theta. Sin theta by cos theta is tan theta. So this also means that if a hypotenuse is given, if you have a question, right, you are given an angle and you have said, okay, this is 200, it's a rope, there's a balloon, the rope length is 200, the angle is something, what's the height? Then I know this is 200 sin theta. How far will it be away? Then that's 200 cos theta. I could have used the blue color there, but okay. Sin theta. 200 sin theta. And this is 200 cos theta. So it can also be used in questions like this concept.